Okay, so we are going to pick up where we left off from yesterday. Um, just a quick reminder of yesterday. This was the last example we did. This example here used this little shortcut, if you want to call it, for these are for roots and zeros of quadratic polynomials only right now. So if you have the roots or zeros of a quadratic, you can use the sum formula here, negative b over a, or you can use the product formula here, which is c over a, basically, if you have the equation. And then you can find the sum and product, right? But if you don't have the equation, you just have the roots or zeros, you can add the roots or zeros together to get the sum, and that would go here in your quadratic equation. And then you can multiply the roots or zeros together, and that would go over here for the product. And then the key thing here is, this is kind of like a shortcut formula. That's a subtraction, right? So yesterday in class we discussed, right, find a quadratic equation that has given roots 2 plus I. Please keep in mind that, I'm giving you both of these roots right now, but I only have to give you one of them because we also learned yesterday that if you have one complex root or irrational root, then its conjugate is also a root as well, right? So if I give you 2 plus I, you should know that 2 minus I is a root, or vice versa. If I give you 2 minus I, then you should know that 2 plus I is a root. Here I'm giving you both, so we're finding the sum. We're going to add them together, and that gives us 4, okay? That is going to go right here, where the sum of the roots goes, right? And then the product, we multiply them together, so that's a binomial multiplication for the roots here, right? So you distribute, FOIL, whatever you call it, but you're gonna multiply every term in the first binomial to every term in the second. And you go through your distribution and you get this group here. The middle two terms, negative 2i and positive 2i, these will always eliminate each other because you're multiplying conjugates, and that's how conjugates work when you multiply them. Remember, I squared is equal to negative 1, so that's minus negative 1, or which becomes plus 1. So plus 1 and 4 give us 5. So here we can use that little shortcut formula and express it as x squared minus the sum, which is 4x, plus the product, which is 5, and be done with it. Now, I personally like this process a little bit better. You're kind of working backwards from the roots. So what I do is we're going to take the roots that we were given and set them equal to x, right? So basically what we're doing is we're kind of working backwards from a quadratic equation that we solved and ended up with these two roots, right? So the first thing you want to do is isolate the imaginary value. To do that, you're going to subtract this 2. If it's just an imaginary and there's no real part of this value, then you don't really need to move anything to the other side, right? So now we do that, now we're left with x minus 2 equals plus or minus I comes from the square root of a negative, right? So really what you're looking at here is, this is kind of like the same exact expression, right? This might help you make sense of it, right? So we don't want this square root, right? Just like over here, we don't want this I. And to undo a square root over here, we would square both sides of the equation, right? So you'd have this and this squared, right? So same process. You can work right off of this line. You don't have to look at that blue line to the right there, but we're going to square both sides here. So the first one, just be careful. It's a binomial multiplication here. And then on the right side, plus minus I squared. So when you square a positive value, it becomes positive. When you square a negative value, it becomes positive. So the plus or minus here, it just becomes one positive, okay? So some students get a little concerned. They think they have to do this twice. You're only doing it once, and when you square positive or negative 1, that becomes positive 1. So this becomes 1, and then I squared is right there, right? I squared equals negative 1. So really what we should be writing here is a negative 1. Go through and FOIL on your left side. So this is going to leave us with x squared minus 4x plus 4 equals negative 1. And then we add the 1 to both sides. And then we end up with x squared minus 4x plus 5 equals 0. This is the exact same answer that we had on the previous slide, just using this process, which I personally like better. It's more of an analytical approach. You're not memorizing a formula. You can use either method you want, but I just think this is a little bit more efficient, in my opinion, than using this technique here, right? Either way, your choice. Another example for you to try. One has complex roots, the other one doesn't. You know, these, you know, I would just, you know, try them. Right, so again, we're going to move that constant to the other side. So we have x minus 2 equals plus or minus 3i here. We're going to square both sides. Right, don't forget when you're squaring this, it's x minus 2 times x minus 2, okay? So when you do that, you get x squared minus 4x plus 4 on the left side of the equation, and on the right side, that positive and negative 3, when you square it, it becomes 9, and I, when you square it, becomes I squared. I squared, remember, is equal to negative 1, therefore that's a negative 9, and we're going to set it equal to 0, so I'm going to add 9 and end up with x squared minus 4x plus 13 equals 0, okay? Now, that was this example, and the previous one were with complex roots, but it also works with irrational roots as well. Take the roots, or zeros again, set them equal to x. Same process. Move the constant to the left, so you have x minus 3 now equals plus or minus square root 2. We're going to square both sides. Again, you don't have to write this, but it's just helping you remember that this is a distributive operation. You're not just squaring x and negative 3, right? So you have to FOIL that. So that'll give us x squared minus 6x plus 9 equals, and then on the right side, positive negative squared, that becomes a positive. Remember, there's kind of like a 1 here. So think of it squaring as positive or negative 1, that's positive 1. Square root 2 squared is just 2. Right, let's clean that up. It's just 2. And then we set it equal to 0 by subtracting 2. X squared minus 6x plus 7 equals 0 here. Right? Pay attention to the directions. I'm going to go back up and look at them real quick. It just says write a quadratic equation. Okay, so what I did here is this is an equation equal to 0. If it says write an equation, make sure you set it equal to 0. If it didn't say equation here, it said function, and instead of setting it equal to 0, you'd set it equal to f of x. But that's pretty much where we're at. And then same thing. And then we jump in to, no, that was the assignment from yesterday. And then we jump into one more example, which I'll put up in a second.